So things people probably should address when they try to approach microservices. A lot of stuff from fallacies of distributed computing. If you haven't heard of those, please check it out. I know, keep it under your pillow or something. This is really important. I will upload this somewhere, so this is a link. You can click on it and read about it. And there are a lot of other things that people don't think at first when they start to work on microservices. There are things like tracing requests across different services. You know what was the most common error when I first created my microservices? So think about this example. Somebody calls your first microservice, and there's another service that needs to be called. And the data is not there. So what happens when the data is not there? 504, right? So the 504 is returned to the first microservice, but it expects a JSON body. And the JSON body is not there. So what it does? Well, it's translated into 500 because there was an exception. So there, somebody fills a report. When I'm doing a post into that service, it returns 500. You look at the data, and well, it looks fine. So what happens? And if you don't have tracing, you will be in a trouble because you even don't know where to look. And there are other things, like, for example, service discovery. You don't want to hard code your addresses, right? Message serialization, that's a thing for another presentation, how to do this correctly and how not to couple two services too much with each other. Distributing load across nodes. You have many nodes, why don't we just distribute the load, right? And other things. So this is, now I will tell you my story. So when we started to work on breaking down some part of our system. So my company was historically a .NET shop. You also think, if you don't know .NET, it's like a Spring-free something bit monolithic application you don't want to hear of and work on. And at some point, someone said, OK, so we're moving to API-first approach. So API-first approach is break it all down. Let all the services communicate using APIs, no common database or something like that. And I was put in a position with my team to take one of the business features of our platform and using whatever tech stack we want to break it down, to add some features, to repair some bugs. So we went with Eka HTTP. And well, we were pretty happy about how it went. We still use Eka. It is fine, but we felt that some things were not as they're supposed to be from the beginning, and we were missing some things. Like, first of all, we wanted to have an easy way how to communicate between our microservices, and we didn't want to use Aka clustering. Why? Aka clustering is cool if you have some part of your system that is not dividable into more parts. But if you use Aka clustering for things that are for two different things, then you got something I would call a vendor lock-in. So you cannot call it from example for your microservice from example Python because there is no Aka for Python, right? I saw something like that with the .NET example. So .NET gave you some pretty cool things like, hey, you want to generate a SOAP service? Yeah, sure. Next, next, next. Then you got some kind of service that no one knows how to call except using that library that was generated 5 years ago, and nobody knows how to use that library. So we didn't want to use Aka clustering for all the services. To be honest, Aka clustering is very nice, and we use it also, but for something different. We found ourselves recreating some utils for every of the microservices that we created. For example, retrying requests. This is a very common pattern. If you call a service, the call may fail, but you might want to try again, and it may success. So, so you need to create those utils because they are not there. When you create a lot of microservices, like let's say once a week, twice a week, you spend some time creating the whole project layout, something that doesn't bring any value. So you need to, for example, I don't know, attach metrics to your project. So your project would send out metrics. This is something that you don't want to spend time 2 times a week, right? Because you're losing your money on that. Something that was pretty surprising for me was that when you have multiple projects and you work on those, and you need to switch between those. Like, let's say you're using Eclipse or IDEA or something, and then you say that you're changing the project. And every project looks a little bit different than the previous one that you worked on, and you need to do something like a mental switch. How do you turn on? Where's the main? What's the entry point? What are the login settings and things like that? And this seems like something very silly, but it's actually a problem that worked for me and for my colleagues. Something we felt that, well, REST is good. A lot of people are using REST, but why would we use a human-readable protocol for communicating machines? Maybe there's something better for that. And one thing that I am fighting is still, I really hate the spray DSL and the Marshall Sinaka. If you know those, I can never get them right in the first time. Yeah, and there were other things, like, for example, I know versioning our APIs, you need to take care of that. Things that brings you a bit of pain every day when working with microservices. So you start to think, so maybe there's something that can ease the pain, something you could use, and like all of the things that I actually talked about, they can be automated, right? They are not easily automated, but they can be automated. So maybe somebody did that before us. Yeah, and we tried the Finagle. So now I'll go into the Finagle part. At the end, I have some demo code. So if something is not understandable, please feel free to interrupt me, because like the things that I'm going to show looks very easy, but on the other hand, I know maybe they are easy only for me or whatever. So feel free to ask questions during the whole part. OK, so what is Finagle? So Finagle is actually, it was created as a protocol agnostic RPC. The protocol agnostic means that it's not attached to HTTP or anything. You can create clients and servers on Finagle that will talk Memcache, Redis, or whatever you want. There are actually clients for MySQL and Memcache and some other things. So Finagle was built in Twitter. It empowers all of the core platform. As they say, if you will try to download my presentation, there's a link. Your server is a function by Marius Eriksson from Twitter. You can read the paper. There are some comments on why did they create Finagle. You can try to, reach the source of how the Finagle was created. OK, so the foundations of Finagle. So there are 3 foundations: features, services, and filters. I guess features are pretty well known among people, right? Like, well, mostly people know what features are, so I won't get too deep into that. So unfortunately, the Twitter feature is not the Scala one feature. Actually, there are more than one feature in Scala world. This feature actually predates the one from Scala and has a bit different API. From my experience, other classes that are somehow connected, like try and duration, and of course Twitter has its own duration and try, and you need to live with that. Again, this is not something that is a very big problem. You got conversions between forward and back for the Scala ones and Twitter ones, but well, this might irritate at the beginning. OK, so second building block of the Finagle is a service. So service is actually the basic building block, something that will be your abstraction for our clients and servers. As you can see, yeah, no pointer. Maybe this one. This acts as a pointer. OK, whatever. As you can see, so service is actually a function from something to future of something. So nothing unusual. But with connecting this to some other things, well, it gives a lot of power. So as I said, service will be used to create services and clients simultaneously. OK, so here's an example of a local service. Local, like I mean, this is not for calling something over the wire or anything. So we're importing a Finagle service and importing future from the Twitter package. This is actually MK is a factory method. You could create a service by doing new service and overloading the apply method. Yeah, and this is just a shorthand. So what this service do, it takes a string and it takes the length of the string and returns the length of the string. Like nothing very new, right? OK, now it will get more interesting. So this is a HTTP server, how you do it in Finagle. So you create a service. Again, this is something that takes one thing. Here's it is a request. And it returns a future of something. And this time it is a response. So what our service does, it takes the request, copies its HTTP version, and returns that version with the status OK, so 200. And to create a server out of that, you pass the service to the serving method, bind it to a pod, and that's it. Now let's look at the other side, so the client. So again, we create a service. Look at that, again, it's a service. This time we're working with a client. It was then a server, but it's all the time a service. So we take a HTTP client object. Fail fast is just a configuration option. Let's just now skip it. We say that we want a new client that will be calling localhost on port 8080. Actually, you can put multiple endpoints here. The client will take care of doing the load balancing and taking care that if the server goes down to don't call it. And if you have a created service, you can use it to pass a request object with some HTTP method and a path, and it returns a future of response. Again, this is not something very unusual and something that would be mind-bending or something like that, but bear with me. This is an example of other clients. This is actually an old API. Now you build clients differently, but I didn't know how to build a MySQL and Memcache client, so I copied the old ones. Just wanted to show you that Finagle can be used not only for HTTP or something like that. OK, so thing that you could notice that the thing that you create, clients and servers, are somehow symmetrical. You do the same for creating both. So now there are some things that you might want to extract from both and attach to servers and clients. And those things are called filters. So this is the third thing that Finagle is built on. So filters are used for things that are not are application agnostic. So those are things like, for example, timeouts, retry policies, some statistics, authentication, things like that. And what's a filter? Again, filter is nothing more than a service, than a function. What filter does is it actually takes a service of some kind, and it transforms it that it will create a new service that will take some other type and will return some other type. For example, the example will be on the next slide. So the good thing about filters is that you can take a lot of filters and combine them using and-then method. There will be an example in the future slide. And this is what actually gives Finagle a lot of power. So let's look at a very simple example. So here we have some string metrics. this is the same example as from the previous slide, that you take a string and return a future of the length of the string. And now we create a new filter. And what that filter does, this is of course a dumb example, but I want to keep it simple. So instead of taking string, it takes a float. And instead of returning int, it will return a Boolean. So it takes a service, that's a string to int, uses it, and returns a value of new type. And this is how you compose filters with services. And now the services is somehow different from the original one. Like, this is a more live, this is a more example of something from life, so that you can actually see when coding. So we create a client, HTTP client, that will connect to Twitter.com. You can send a request there, and we want to have something that is called timeout filter. So timeout filter does, well, what the name says, it actually timeouts if the request takes too long. And so the new service still is request response, but this time it behaves differently because you've attached timeouting. And this is how we create it. You take a filter and then maybe another filter and a service at the end. And maybe anyone has an idea how to implement this. Remember that service returns a future of something, and now you want to time out that future. This is actually something that is not so hard. You can actually start 2 timeouts, and there's a method first off that will return the first completed future. The funny thing is that I actually implemented the timeout filter. I didn't know that it was already in the Finagle stack. And it actually was bad because my timeout filter was very primitive, and the one that is given to you with Finagle is actually very advanced and do things that, well, you wouldn't do on your own. Okay, and this is an excerpt from the paper that I've mentioned, your server as a function. This is an actual composition of filters that Twitter had at the front-facing the internet servers. So what they did, they recorded some handling time, trace requests, they collected statistics from the JVM, past requests, a lot of things, right? Yeah, so if you would be interested in using Finagle, you should definitely check out those filters. They're worth using, and now try to recall problems that I said that you will have with microservices. So you have filters for handling exceptions. You have filter that will take care of exposing your metrics for free for you. Retrying filter. This is actually something that is more advanced than it might seem at first, because the retry filter can take a retry policy. For example, you can say retry 5 times with a 1-second break after all retries, or maybe retry with an exponential policy. You can attach some kind of budget that some service can retry multiple times and will burn its own budget, and then it will go down. A timeout filter, I said that I've implemented it not correctly because, like, you know, the timeout is actually something that is more hard to get it right when talking about connecting over the wire, because you have things like connection timeout, idle timeout, request timeout. There are multiple timeouts, and writing it on your own is not so easy. Load balancing. This is something that's really handy. As I said, when you create a client to a service, you can put multiple addresses, and Finagle will take care of calling them. And it will even check which one of those is the most overloaded. You can say what kind of metrics you want to use. For example, how much heap is used on that server. And if it's too high, it won't call that server. Fail fast. This is also something that comes handy, but it's not so obvious at the beginning why you should use it. So if some kind of server goes down and a request comes to your system and the request cannot process because some microservice is down inside your system, then your microservice at the front will try to call it. But there's no sense because no one will respond, or it will take too much time, right? So fail-fast filter will do something like that. OK, this service didn't respond the last 5 times, so I will mark it as dead. And all the requests that will go to that service, I will reject at the beginning of it. And then after, let's say, 1 minute, I will try to contact it and see if he's alive. If he's fine, then I will unmark him. And this is very handy. And well, I've told you that all of these things can be implemented as filters. And this is actually a bit a lie, because not everything can be very easily implemented as a filter. Some things are a bit hairy. For example, have you ever considered how to cancel a request? What should happen in the system when you cancel a request? So when you have multiple microservices and some request comes in, then you can span some work inside your graph of microservices. And when you do a cancel here, well, you probably should not only cancel here, but also everywhere where the work started, right? And what is the most used abstraction in Scala for returning something that will happen in future? Well, future, right? I said the name. And you probably never think of it, but future is actually one-way data flow. You have a consumer, you have a producer and a consumer of future, and the data flows only one way. You cannot cancel it, right? And so you cannot use filters for that. But Finagle did some hairy stuff beneath that you don't want to know about, and it works. Yeah, so the implementation is non-trivial. I've read the code. It's worth reading. The good thing is that if you go with Finagle, all of this mostly works out of the box. You don't need to do anything. This just works. All the load balancing, timeouting, and everything. So all the things I was annoyed using other stacks, well, they're there for free. And there is more in Finagle to explore. So does anyone knows what a thrift protocol is? Well, thrift is not very well known. Maybe Google protocol buffer protocols? Yes, so for example, let's say that you have something that's called a meta description of your class, and you can take that meta description and go to a parser and say, generate me a Python class out of it. And you go to another thing and you say, generate me a Java class out of it. So with thrift, you can do that. This is the same what you can do with Google buffer protocols. But also thrift has something like server and clients. So in Finagle, you can take a thrift meta description of a service, take a SBT plugin that is called, I think, Scrooge, and it will create you a client, a service for free that will load, balance, timeout, and everything. And you don't need to write all that pesky JSON stuff all the time. Of course, this will be a binary protocol, so you won't be able to look into it. But you save a lot of time, and thrift is easier to maintain different versions for. Like if you want to change something in the thrift protocol. Yeah. So this is one thing that's worth exploring. Another thing is multiplexing. So multiplexing helps with using the whole bandwidth of your wire. So I know if all of you know that a lot of servers do something that is called HTTP pipelining. So HTTP pipelining, if somebody doesn't know, is something that normally you should create. If you, let's say, open a website, right? You get a lot of resources to download, and you should open a socket for every of those resources, right? But you don't have to. You can do something like open one socket and send, like, for say, 10 HTTP requests using that socket. And it all would be fine, but the responses need to come in the right order. They cannot be mixed. So there happens to be a phenomenon called, I will read it because head of line blocking. So for example, some resources are ready to be sent to you, but they need to wait for the first resource that was asked. So multiplexing is allowed to avoid that problem. Another thing, Zookeeper support. Does anybody doesn't know what a Zookeeper is? Okay, so a Zookeeper is actually something that is used for doing, well, I forget the word. You want to have a distributed system that will agree on something that, for example, this client has died. So Zookeeper is for that. And you can also register some data in Zookeeper, and it will try to keep all the clients of it informed and up to date with that data. And you can use Zookeeper to address your services. You don't need to hard code your addresses. You can ask Zookeeper, and you can register yourself in Zookeeper where are certain services. The last thing is network location naming. This is not something that I used in any of my projects, but this helps you with rewriting addresses of your services. And like Twitter said that it might come in handy when you have, I know, all the services and you want to change the environment, for example, from dev to production, and you change the rules of rewriting URLs. I know, if anyone wants to know more about it, there's a page about it in the documentation. I haven't used it, just mentioned it here. Okay, so that was Finagle. And there's more. So as you may already see, Finagle is a bit low level. Like you need to do a lot of stuff on your own. It does a lot of things for you in the sense of, I know, load balancing and things like that, but there are still things that can be added to Finagle. So Twitter created something that is called a Twitter server. I would say a pretty dumb name. So Twitter server is built on top of Finagle, and it's actually something that is a template for creating services, for creating servers. And it gives you basically 4 things. That is flags, logging, metrics, and admin interface. And let's go all one by one to all these things. So flags are remedy to thing that I already mentioned, that you have multiple microservices projects and you don't know how to turn it on. So every service needs to get some data from the outside world. It might be, for example, where's the Redis server? Where's the MySQL server? What port should I bind to, right? So, and people tend to do this differently. One will prefer to pass it as a system property, other will use things like environment variables. Some people will pass it as command line arguments, and flags are answer to this. So flags are something that actually you wrote in the code what kind of arguments you need. And flags are pretty smart because, well, they can actually understand Scala types. For example, you can pass something like 1 second as a command line argument, and it will understand it. It has a help command automatically if you use Twitter server as your template for your service. And the best thing is fail fast when there's a missing flag. Believe me, there's nothing worse than a running service that is running differently that you think that it's running. Like, for example, connecting to a different database. You can spend like an hour debugging it. Yeah, okay. Logging. So logging seems like a fairly understandable idea, and what's more into logging, right? But again, logging is something that people tend to do differently. One will create an XML file, somebody will do it in some other files, like in code or something like that. So in Twitter server, logging is configured with standard flags, the flags that I mentioned. And what is really nice, you have an admin panel that actually allows you to turn on and off different loggers. as evidence of that, those are some system loggers, and this is actually from my code, from the other package. One thing that's maybe missing, I would like to, turn the logging level for all the services of one kind. Like, for example, if you have a service for authorization, you would want to turn in all of those some level. Okay. Metrics. Twitter server gives you option to define your own metrics. For example, I know you can count the number of requests that came to our service, but you don't need to, because Finagle, as always, has a lot of defaults, and it does it for you for free. You get also JVM stats exposed. You get some network stats, processing stats, a lot of things. And again, you are backed by admin panel. So you can look live at what's happening to your service. And you can see that there's a lot of things that you can actually trace. Like, for example, number of 200 responses, number of 500 responses. When I will run the demo, I will turn on the admin interface to show you. Other things that are very unusual. Linting your servers for problems. Okay, so probably a lot of you have used linters for code, but have you used linters for your servers? So Twitter can actually tell you, you know what? Your service is actually logging a lot of things, and it is slow because of that. Maybe you should turn the logging down. Or it can say to you, you know what? There's another service with the same name, and it's causing us problems, so you should rename that. Actually, it does that. It has rules for the live code that's on production, and it will tell you that something is bad. Other things you can, you can look at threads in the admin panel, which one are blocked and things like that, and do profiling with pproof. Pproof, that's the name? I guess so, I don't remember. Yeah, and again, a screenshot of the admin panel. I will turn it on when we come down to the demo. Okay. And if that is not enough for you, there's even more. So on top of Finagle and on top of Twitter server, there is something called Finatra. So Finatra is, maybe you've heard about Sinatra, the Ruby framework. So Finatra is something similar. So it does all the heavy lifting of creating HTTP services that you would probably do. Well, I've bashed JSON a lot, but in the end, you will probably need to create at least JSON for people from outside of your company or outside of your team. So this is where Finagle actually, Finatra comes handy. Let's go down to what Finatra offers us. So first thing is dependency injection using Juice. This might come as a surprise. Well, personally, I'm not a big fan of using frameworks for dependency injection. I never was. But Finatra does it so well that I'm actually very pleased to use it. I will show you in the examples. As I mentioned before, so Finatra takes care of handling JSON with Jackson library. It gives you Mustache support. I don't know, I never used Mustache. Maybe you used it. Like, this is templating engine, right? I think so. Routing. So the basic Finagle doesn't have anything that gives you routing. That's of course needed very much. And the best thing, as always, it takes all of those things and integrates them. They work really nice together. So an example of a controller. So you want to create a service, a HTTP service to be precise, that will respond for a get at a path recommendation, some variable and some variable. And it will use your recommendation engine before using the recommendation, tracing the call and respond with the recommendation. And look, what Finatra gives you is easy way of defining, for example, what are the parameters here. You create a case class. You annotate that cookie ID is a root param, eShop is also a root param, and you expect a header, X out. And the best thing is that you can see that there's a lot of annotations. I know maybe you don't like annotation. Most Scala people don't do. I don't like annotation also, but it works really, really well here. So example, if you forget about one parameter, like I said, both of those, eShop ID and cookie ID, are ints. For example, we call it with 32 and VSF. That is not an int. So it will give you a batch request, and it will tell you, you forgot about that. You forget that cookie ID is not a valid int, and you are missing a header. So it reports what are your actual mistakes. And believe me, if you have, let's say, 20 microservices and you're debugging something, you don't remember all the curls, things, and what parameters you need to pass. And this is really handy because you really fast know what is going on. JSON support. So JSON support mostly works out of the box. You don't need to create any serializers, anything. You just return an object. Like for example here, the tracing filter and recommendation engine creates a service that returns an object, and this will be returned as a JSON. And you don't need to think about how to create that kind of object. Of course, you can somehow change that, how it will be serialized, but you don't need to. It's, of course, well integrated with standard libraries that you would use, for example, Yoda, maybe now with Java 8. Yeah?
Can you move up?
Yeah, sure.
So,
here or here?
yeah, here.
Yeah?
So this recommendation from cookie request. All right. No, never mind. I was thinking that that's some kind of a dynamic variable, but I see that's just a case now.
Yeah. Okay. I was here. Errors accumulation. So the JSON support is also well integrated with this. So as I said, if you miss, for example, like here that cookie ID was not a valid int, if you would expect here a JSON, so all the problems with your JSON would also be reported here as errors. So it is also integrated with the routing. Yeah, this is how you actually customize your JSON. This is also very handy because you don't need to do a lot of things. This actually happened to me. So I had a service that wanted a snake case JSON, and the other wanted how we call them? Camel case JSON. So this is how you create an entry point for the Finatra extending HTTP server, and then you have some definitions that you need to override, and then you put your own modules. And so what this module does is it creates a serializer for the data type local for the local date, and changes some settings, like for example, include non-empty, use camel case, write numbers and strings and things like that. This sometimes really comes as something very handy. Validation. Validation was based on something that's called JSR 303, if I remember correctly. So it's based on annotations. Again, I hate annotation, but here it also works very well. So you can put some annotations on your case class. Those problems will be reported in the errors JSON that is returned. So this is also very well integrated. If you need to check, for example, two fields, you can write your own method that will check it and annotate it with method validation. Yeah. Testing. That's another thing that Finatra is really good at. And that is one of the things that I really was convinced why I want to use juice and dependency injection by annotations. I will show you when I will turn on the demo code. So Finatra gives you two ways of testing your HTTP server. So one is feature testing, and it's both black box and white box. So actually, it starts your service as it is. So you can, it embeds a HTTP server for you, starts it with your roots and everything, and you can test it. But like I said, this can be black box testing, so you can test it as it is configured. And white box texting, you can say that, you know what, behind that controller there's a service, a Finagle service, mock it and use this one. So don't contact an external service. I will show in the code how easy it is done. And another thing is integration tests. So Finatra is built around something called modules. For example, that module with JSON, right? You saw it. Where is it? Yeah, you saw it here, right? Override dev JSON module. So you can say that you want to test only a subset of your. Sorry, I've run too long. So you can want to test only a subset of your modules. So example, I want to test only my JSONs. So integration tests are for this. And Finatra doesn't mess anything with your unit test. This is up to you how you do it. Another thing in testing. So smart JSON diffs. So if you say that you expect a JSON from your service, the JSON differ actually understand that there can be spaces, that there can be some, I know, inconsistency in formatting of the string, right? It doesn't care. It just needs to be the same JSON logically, not in the form of it. As I already said, it's well integrated with dependency injection. It has easy mocking embedded. Okay. Oh, I all said that. Okay. So this was Finatra, and this is not the last thing that you get with Finagle. The last thing you get with Finagle is something called Zipkin. I don't know if you heard of it. This is actually now not really tied to Finagle. So what is Zipkin? So Zipkin is distributed request tracing, so something that will give you insight into your system when you have a lot of those multiple services that call each other. And well, Zipkin is based on a paper from Google called Daper. Daper? I don't know if I misspelled it. Whatever. So Google published a paper on how to do the distributed tracing of requests, and Zipkin helps you to do the tracing. And it's well integrated with Finagle. It looks something like this. So, for example, you start to call this server calls this server, and this server calls la 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 la. Those two were actually started in parallel. This didn't call this, but they were started like simultaneously from this. And you can look at the times. And believe me, this is something that's actually very useful when you try to find out, well, why does my service times out on some data? The good news is, if you will not use Finagle, is that Zipkin is not tied to Finagle. You can use it from other languages and other libraries. So for most of the people who maybe will not use Zipkin, they can use Brave from Java, and it will do the same thing. Just as an ending stuff, Zipkin architecture. So Zipkin architecture is actually, this is not a small application. Actually needs a Cassandra database or some other database to store those traces. It has a web UI and a query engine and it's Zookeeper, so it's pretty sophisticated. Okay, so I got a demo app. I don't know, maybe you are tired and you want to hear about the demo app. You want or not? You want, okay. So, so the demo app is pretty simple. So this is something, an excerpt for something that I did. So you need to do a recommendation for a banner. You get a cookie ID and an eShop ID. You need to get products. You need to get promoted products for that shop. You need to get a user profile and return some recommendations. Okay, let me turn on my IDE. At the same time, I will show you some of the real applications built on Finagle and how those look like. Finagle. The whole code is actually on GitHub, so if anyone wants to look at it, it's no problem. Yeah, maybe before going into code, I will actually first run it. Finagle Spike. Okay, so we need to run the recommendation application. As you can see, Finagle puts out a lot of infos about your server after starting. I don't know if this can be seen now, but for example, well, it writes out actually port that it's serving on. I know this might sound silly, but have you ever tried to call your service and you didn't know which port it started on? Because I have. Yeah, so also the actual routes that were added. This is also something that have you used Spray? Have you ever forget about that, I don't know how it's called, symbol that is next to, on left to the one? Yeah, but I know what's the English name of that. Tilde, okay, so it's tilde. So if you forget about that, so some of the routes will not be added to the actual serving. And yeah, that takes time to debug. Yeah, and all those routes are here. Okay, so this is the recommendation. Let's start also something that will take products. Another one, because like we're doing microservices, so we have failover and stuff like that, right? Okay, this is user. I will start only 4 of them because I don't want to make too much, spend too much time. Okay, all of this is started. Let's call it with curl to do our little recommendation. It will take some time for the first time. And look at the logs. Okay, why does only, oh, I need to scroll it down. Okay, now it will be faster. Okay, so you see that it's load balancing between servers, right? Yeah, okay, so let's kill one server. Yeah, it's still fine. Let's swap the server, kill this one, and start this one again. Give him a second. 500. Yeah, he's up. And that is for free. You saw how I created a client, right? I did a HTTP client and passed these URLs. So this is all I did here. I will show you in the code. Okay, so let's look at the localhost. Let's look at the admin panel. So this is my panel that's for the recommendation engine. I don't know why Zipkin Tracer has success rate 0. Oh yeah, because I haven't started it. Good thought. Let me start the tracer. GitHub clones. About Zipkin, so it's best to just start a Docker image if you want to try it out. Yeah, it's running. Okay. So you got all the downstream clients here. You can look at those. What else we have? Well, we have a lot of metrics that you can watch. I would need to call it to see the graphs. You saw it on the presentation.
Can you call a service from UI?
No. No, there's no such option. This is not what I... Okay, the metrics that you have. So there are a lot of metrics that are for free for you. Like for example, latencies, a lot of latencies with different timing. A lot. For example, how many 500 have you returned up till now? Stuff like that. Yeah, and it's per route, right? The percentile and time. You can actually see that you return 500 and you spend a lot of time just to return that 500. Okay, what else? Or you can shut down the server using the UI. I know if this is very useful. You can look. Oh, I haven't loaded heaps, so sorry. Yeah, you can look at the blocks threads. Well, there are a lot of things that you could actually use. Oh, there are so thread events that are shown here. What happens that, I know, the counter was incremented, that statistic were added. This is the control of the loggers. And nice things, actually. Something that you might want to use. Let me show the Zipkin interface. That's 8080. Yeah. So, for example, recommendation engine, find me traces of recommendation engine. Yes, so recommendation engine called product service to get recommended products for an eShop, for all the products for eShop. He called it again because eShops have some products that they want to promote. Then it called user profile service, and then it returned response. And you can look at the timings. So server receive, client send, client receive, server send, and things like that. And this is actually not a lot of things to do. Like I can show you now the code. Let me turn on the presentation mode. Okay, let's start with the recommendation engine. Well, this is too big to actually navigate freely. Oh yeah. So this is the recommendation HTTP server. This is the main entry point, and I can show you that actually products HTTP server looks very similar. So all the entry points look the same. So it's easier to navigate between different services.
Do you have Swagger on this service?
Yeah, I've put how to actually add Swagger controller. So if you would like to look at GitHub, so this is, the Swagger file is actually corrupted because I actually put my Swagger file from my work and I had to delete it. But it works. It will serve the Swagger file. Okay, so this is the controller. You saw it at the presentation. All the things that I've told, like annotating stuff and things like that. Okay, so let's look at the services. So this is recommendation engine service. It's automatically injected because it's a singleton, and this is a very important thing to do to keep your services stateless. And the recommendation engine uses two other services, right? Product service client and user service client. And what it does, this is something that you know very well from using futures in Scala, right? You just call one service that returns a future, another one, a third one, and then you mix it up all together. Don't look at this part of the code. This is actually something that I only made to return some results. This doesn't make any sense. Yeah, I promised to show you how the testing works. So yeah, this is actually very nice. So look, you create an embedded HTTP server with your recommendation HTTP server, and you say that I want to do white box testing, and I say, because you want to mock recommendation engine. Remember that recommendation HTTP server had the recommendation controller and it used recommendation engine, right? So it's like 3 layers down the bar. And here I say the recommendation engine in the test needs to be mocked. And I want this recommendation engine, when you supply it with this argument, that it should return this. So this is from Mockito, actually. And then you get the server, and you do a HTTP GET on it with a path, with a header, and you say, I expect it to return OK and a JSON body like this. And as I said, the JSON body parser doesn't care about formatting, so it can be a JSON like this. It doesn't care. It will understand that this is the same JSON. Yeah. OK, so maybe I will also show how to use those services. Oh, yeah. So as I showed that I've started some services, right? So you can pass a number of addresses that you want to contact, and this will happen automatically. And this is actually something that actually I only use. This is not something that I saw in the documentation. When I want to contact some kind of HTTP server, I create a service from request to response, and I create filters that take that service and has a query string hard-coded here. Anyway, if anyone is interested, I think it will be best for you to just look at the code at GitHub. If you want to start it, all the instructions are in the README. Yeah, I think that's it. Thanks. Oh yeah, questions, right? Sorry if anyone has questions, but I don't know if we're out of time.
Did you write manually Swagger model or just generated it from code?
No, it was written by hand. Zipkin didn't work. Why?
I know.
Why it didn't work?
There was something like 0%. Somewhere in the admin panel. Because you didn't run it before, right?
Oh, maybe. Maybe. Oh, yeah, again, with Zipkin, like, this is actually a very simple example because you only got 3 of those, right? And I have something that has a lot of called microservices. Look at this one. Well, actually, Zipkin has something like a tool, fill my Zipkin with some dummy traces, so you can look at those. So this is a dummy trace. If you have a lot of those microservices, well, it gives you more benefits, right? So you can look at those. You can see that this one, why doesn't it? I don't know. OK, let's leave it like that. Yeah, OK.
And a question from me. Earlier you mentioned that there is something in Finagle that helps you with canceling of the request. And I wonder if there is something that can help you with stopping a computation that is done in progress as part of some, let's say, Scala feature.
Yeah, so actually, I didn't know this until I've created this presentation. In the paper that I've mentioned, your server as a function, Marius Eriksen says that they did something that actually allows you to cancel all the downstream work that you scheduled. I don't know how, but they said that they did it and it works. It breaks the whole beautiful mathematic model of the future, but it works. And I believe them. Like, they give me their words. Like you know, they Twitter. They probably know what they're doing, right? Something else?
So, quick question about Zipkin. So, never heard of it. It looks cool. Do you need to like pollute are your code base, are your microservices or services to get it working, or does it work in some magical way?
Okay, so for Finagle, actually, for example, every HTTP client has a tracer attached, and if the Finagle jars are on the class path, it will automatically connect to Zipkin, so you get it for free. For your services, the one that you create, you need to create a tracing filter in front, and I had it somewhere here. Wait a second. Recommendation controller. It's probably too small. Wait a second. I will. See here? Tracing filter.
Okay.
And that's it.
So for example, if we gonna do like a couple thousand consecutive requests, will it like kind of figure out which requests pair together instead, like for example, you request product A, get back, then access, then request product B. The product A is returned, product B is returned, and will it like trace logs and it will be like find you know.
Yeah.
Together, or will they be mixed?
No, he will. So actually, if you create a lot of services and services call services, right? So you build something that you would call a graph of services, right?
Yeah.
And the tracing understands that graph. So it understands the flow. Like in that, you see, this plus should actually work, but if something is on the same level, it was actually called in parallel, right? And if something is padded to right, like for example, those are under this call, right? So this was the initial call. This was the first call. Those were like on the same time. Or those two were under this, right? And so on, deeper into the graph.
Yeah, but all of those components have to have this tracing filter attached, yeah?
Yeah. As I said, if you use only HTTP client, they always have. You don't always want to have tracing attached because why did I attach it here? Look, the recommendation engine actually is a local service, right? It uses two other services to call external servers, right? It doesn't call on its own. So normally, if I wouldn't add that tracing filter, it wouldn't show up in Zipkin, right? You would only see those two calls, those three calls, sorry, but not under recommendation. Okay. Okay, then I guess that's it.
I think I can speak in Polish now. So. Dziękujemy Ci bardzo za przyjazd. Mam dla Ciebie tylko gifcik, 2 bluzy, 2 koszuleczki, 1 zestaw jest dla Twojej żony, bo wiem, że gdzieś się tutaj kręci. Was jeszcze zapraszam na pizzę, bo została, dużo piwa zostało, jeszcze możemy posiedzieć, pogadać, kto tam sobie ma ochotę i czas. Jak najbardziej zapraszam jeszcze do zabawy.